All right, so let's see. Your written test 1 next Wednesday during your lab session, October 29th. And you can look at the practice questions. And I just posted yesterday announcement containing the link to the past semester's review session. So that review session there actually went over the practice question with you one by one. So you can take a look. You don't need to really wait until Saturday. If you want to join the Zoom session for review, Saturday 4 p.m., you're welcome to. But I think if you actually just kind of go over the practice question, maybe on from that kind of recording, and then on on Saturday, you can actually ask me something else. You know, if you want me to revisit certain topics in the lecture, I think that'd be maybe a better use of your time because the recording is already there. I'll let you decide, right? So again, Saturday optional. If you want to come, ask questions, feel free. And your lab number 3 has also been released, right? So that one should be a relatively easier lab to actually complete, but you do have to practice the equals method, which might be needed actually for the later test. Not the coming one, but we'll see. Anyway, I'll give you the guidance before the test. All right, any questions? All good? All right. All right, let's now do a quick recap. And then I do want to revisit that example I tried to create on call by value. I reconstructed that a little bit, so now it should be better to be presented. We'll talk about it. So on Tuesday, we went over another set of examples on call by value. So you just have to distinguish between when the parameter is actually primitive type versus is actually reference type, right? In the case of the primitive type, you simply initialize the parameter using the argument value. Just copy maybe the integer value to the parameter. That one's straightforward, nothing tricky. But when you get to the reference type, you got to be more careful. Okay. So when you actually got call by value, for example, let's say call this method here, which is declare over here, and this is reference type. That means you are initializing the Q, which is the parameter, using the P reference, which is the arguments. And P is currently pointing to here. And if you're initializing Q to be P, that means Q should be pointing to the same objects over here, right? So that's the call by value part, which will be done automatically. You have no control over. And then when you, and the two variants that we talk about for this, one is if you simply try to reassign the parameter into another new object, you're basically just reassigning this particular reference into another thing. That wouldn't change the original argument objects right here. It stays unchanged. So if your intention is to really modify this blue object over here, pointing to by the arguments, you should do variant number 2. In that case, you're basically saying for Q over here, that's kind of pointing to the same objects. From there, you try to call mutator method, right? So I'm going to give you just more example, which I kind of tried to sketch on Tuesday, but it wasn't so well designed, but it's not better, okay? Any question about this example here, about call by value? All right. And then equality. So we spoke about equals and also the equals method. For primitive type, you can only use the equals to compare the value, like a simple value. And you cannot really call the equals method on any primitive variable because they cannot serve as context object. It's just a simple value. There's no like an object kind of a concept over there. On the other hand, for reference type, like a point, you can definitely still use the equals sign operator, in which case you will just compare their references. Or you can invoke the equals method on that particular object there. And that's something we definitely will see, and we see some kind of idea already. So when you invoke the equals method, there are 2 scenarios you have to watch out for. Scenario number 1, if, let's say, the point class over here does not override or redefine the equals method. In that case, we're just going to use the default version that's inherited from the object class. On the other hand, if the point class actually explicitly overrides or redefines the equals method, in that case, we're going to invoke that version instead. So that will be something you have to always keep in mind. So there will be some decision making you have to should be always going on in your mind. But I'll give you another, like a more clearly written out principle, to actually follow. We'll go over that. Okay. All right. So this example here, just the one we did over Eclipse. for any reference type, you can always call the equals method because always guarantee the one that's inherited from the object class is always there. But it's no guarantee you're going to call that one specifically, right? So, but it's always there. And then which version is it going to call? Because in this case, point v1 over here has no explicit definition for equals method. In that way, it's simply just going to call the default version, and that's inherited from the object class. So this definition here, right here, is something we kind of show from Eclipse. And I'm not saying you have to memorize it, but you have to know exactly what that definition is, because that one there is just going to compare references between the context objects. Okay, let's take a look at the example here. When I say p1 equals p2, context object is this. And also argument over here is really the obj over here, right? So we are really just comparing their addresses by default. But if you are not happy with it, you can definitely override it if you wish. All right, and then we spoke about this diagram here, which is also very important. So this is the object class that's in the library. They have many methods there. For example, toString method equals, and also something called hash code, but we don't have to worry about it in this course. For this course, just worry about equals and toString. And for the equals method, the definition just compare references, okay? So idea will be any class you create in your projects, they are going to be the child class of the object class automatically, which means everything you declare in objects, including the equals method, they will be inherited directly to every class by default. So now, in the case of the point v1, because we did not choose to overwrite or redefine the equals method, so that one is going to be used, this default version. On the other hand, for point v2 over here, we actually overwrite that default version. In that case, the default version is no longer applicable. So later on, we're going to study about exactly how to write this overridden version. Some part of it is quite routine, but you have to understand exactly how they're supposed to mean logically. And then some parts will actually have to kind of up to your application need. That's something we'll also talk about. Okay, guys, any questions up to here from last time? All good? Okay. So just before we go back to the equals method, I would like to just revisit this example very quickly, right? That's something I kind of sketch on Tuesday. I think I'll do that. I can also share this example with your fellow students in section B. I think that'll be nice. Okay, let's take a look again. So we got two classes here. We got students, and also we got registry system. And in the student class, we got an array of courses. For simplicity, each course is just a string, just the name, and then the counter. And then in the register method, you can simply add a course into the array. I know pretty well how to do it. Another class is called registration system. And we got an array of students. You can see we got an array called SS, and each element stores a student reference. And we got a counter for that. So now we got two methods over here. So I'm going to show you two instances of the call by value. Okay, so two. The first method here is called register, right here. Okay, this register method here, we got student S. You can see this parameter over here is reference type, right? So that means somehow it's going to copy the address of some arguments whenever you're calling this method. We'll see. And then you're passing a course as well, and then you will simply just register this course into the students according to this definition. So this is kind of complexity, something you definitely have to expect, in the later programming test. I would say this is kind of like a minimum, right, at this point. So just try to get used to this kind of different layers. Another method here is called register all. So we basically just write a for loop and go over all the students in the system so far. And then for every student, right here, you can see SS, the student array, go to index I, says that's going to be a student object, right? We simply pass that as an argument right here and call the register method, right? Which is right here, all right? So there are two occasions of call by value, okay? I'm kind of including some diagram over here so you can maybe start tracing yourself. For the interest of time, you can definitely do the tracing yourself. I'm going to give you some example code. Let's see what's going on here. Okay. So to start with, we create some empty system called a sys right here. And then we create two student objects, S1, S2. You can think about S1, S2, like two students. Let's say Alan and Mark, different students. And then we simply add S1 and S2 into the system. So you can imagine that a registration system is going to have an array, index 0, maybe point to this student, index 1, point to this student, right? That's something we did also earlier. Good. And then let's now look at these 3 lines, all right? I'm going to show you 2 instances of the call by value. Let's see. The first one will be a little bit similar to what we did earlier. Okay, let me highlight it. So let's say if I call system.register, and this is calling this particular method right here, right? And then what exactly is call by value going to do? Let's see. So I'm going to circle the relevant arguments and also the relevant parameter. So they are going to be connected by call by value. So this will be the first instance. So this one here, call by value, is going to initialize the parameter s by s1. And then after that, whenever you refer to s in the body of the implementation, you're really talking about a copy of the address from s1, really. Right? So that's something we can already visualize. You can try to do that as exercise. So that's the first instance. Okay? And if you do another call over here, for example, register, but this time you say S2. It's going to be done in a very similar way. So now, it just rather than initializing S to be S1, it's going to initialize it to be S2, right? So the same scenario, all right? So this one here pretty much corresponds to the example we did earlier, even for the circled example. Nothing complicated, right? You can just see different scenario. What about the next one? The next one is kind of interesting, but still, okay, within our imagination, it's not too bad, okay? So this one here, let's say we're calling register all, right? And register all, right here, okay? Right here, you can say, strictly speaking, there is some call by value happening. In what sense? Okay, but although that's not exactly what I want to talk about, but I can show to you. You can see this is the argument value, like a string reference, right? 2030. And then the course over here is a reference type. So that means the course is going to be initialized to 2030, right? That's definitely a call by value. So you can say this is some bonus for you, okay? So this one here, call by value, he's going to do the course is assign EECS2030. You can think of that, right? Now, this line. I want you to look at this method call. First of all, let's now highlight this line. Because it's a method call, so you have call by value. Whenever you got a method call with some argument value, you got call by value, right? So which method is this calling? Because we say this, that means that in the current class. And then it's really calling this particular method right here. Right here. Oh, sorry. The register. Okay, register method right here. All right? So now let's take a look at this line. So this method here is calling this method here. All right? And then, can anybody tell me how exactly the green highlights how the call by value is happening? What variable is being initialized to what? This is slightly different from what we did earlier, but it's still not too bad. Go ahead. Call by value.
Yeah, student S, like variable S, is assigned to the this.ssi. The student element as that index.
All right, very good. Okay, let's now just repeat what your fellow student said, which is completely correct. So this is the arguments, first of all. And this one here is the parameter, all right? They're going to be connected by call by value. Call by value tells you S should be initialized to this dot SSI. I here is simply the loop counter value, which may be different depending on what the bound is. So you can think about call by value simply happen so many times depending on how many iterations there are. in the loop. All right. So you can think about this particular call by value happens for every iteration. Okay? But the principle is really the same. You just assign, just initialize the parameter using the argument value. It's just that argument value happens to be an array indexing expression. Right? That's the only difference. All right? Guys, any questions? All right, so call by value, we really have seen so many examples, but more will come. I think because whenever you see a method call, you can always talk about call by value. I'll talk about it once more today as well, when we get a little bit deeper into the equals method. All right, so try to trace the program yourself as well. You can put this onto Eclipse, just to dive deeper, because you guys kind of asked me what kind of extra exercise you can do. This will be the kind of stuff you want to do, just to strengthen your understanding if you're not really getting it. All right, let's now move on to today's contents. The first one here is very fundamental because the tricky thing about the equals method is really to think about, should I call the default version or should I call the overridden or customized version? So there is certain principle you will have to follow. Let me talk about that principle in this single page over here. So the bullet points, like over there, the principle, you can definitely read it after the lecture, but I'm going to visualize and also mention that. Okay? But we're going to keep applying this principle even when we get to the inheritance lecture later. Let's take a look at exactly what we're doing here. So we are calling the equals method on context object x. And we are asking whether or not x equals y. And y is the arguments. Right? Let's now just do a little bit of annotation here. Okay? So let's just to start with, in order to, so what we really want to, what we are really asking is the following question. We are wondering about which version of the equals method should be called. Okay? Which version? Okay, that's a question you should always ask yourself. There are two possible answers, no third, just two possible answers. Number one, it could be the default version. Default version from the object class, right? Or it could be, let me say now, some customized, redefined, or overridden version from some class. Yeah, question?
Is there a case where we would want both the default version and a custom version in our code?
No, actually the straight answer is you don't really want both versions to be applicable to you. So only one of them is going to be applicable. So the principle goes like this. If you simply just want to compare x and y over here according to their addresses, in that way, just leave the default version because it's going to do it for you. Okay. On the other hand, if you want to do anything that's going to be beyond just comparing addresses, you should override it yourself. That's the principle. Okay. Good question. All right, so point number two, it could be some overridden version. If it exists, but I'm going to talk about how you can check. Very easy to check. Okay, if it exists. All right, so that's really the question we're asking. And one more thing, how do you really figure out the answer yourself? So let me just highlight it, right? That's a question we're asking whenever you got a equals method call. Okay. X and Y here, only one variable matters for your decision making. Context object X. Okay, I'm going to write it down explicitly. To make that decision, like which version to be called, the context objects is all that matters. To determine the version of equals method being called. It's a very, very important principle, okay? Okay, let me highlight it and I will just repeat again, okay? Just in case you're not capturing the point. Whenever you're calling the equals method, you're asking, should I call the default version at the runtime or should I call the customized version at the runtime? To really make that decision, step number one, look at the context object only. You don't have to worry about argument at all, right? Which version, all right? Good. And step number one, you look at the context object. Now, so let me visualize it. So X is a variable that stores the address, right? So let me put it here. So X is pointing to some objects right here, okay? And remember the mechanism for visualizing object, we usually put a title in the box corresponding to what kind of object it is, right? So let me just say some class over here. So the sun class over here can be vaccine, can be distribution center, can be point V1, can be point V2, any class. Okay. So as soon as you put the title in the box over here, so this type here has a special name. Okay. Let me introduce it for the very first time. Okay. The sun class over here is something called the dynamic type of X. Dynamic literally simply means it might change as you actually execute your code. For example, let's say X right now is pointing to a box of this particular title. So that dynamic is some class. Later on, we might decide to reassign X to another box, in which case it might have a different title. In that case, dynamic type is different. Right? So dynamic type might change. Okay, it may not stay the same. All right, so now once you figure out the dynamic type, here is something as a last step you have to say, okay? Okay, and then you have to look up the definition of that particular dynamic type, which is some class. And there are only two possibilities. I'll mention that first, and I'll write it down. Possibility number one, if some class does not explicitly override the equals method. In that case, at this point of execution, call the default version from objects. Possibility number two, if some class does contain some overridden version. In that case, at this point of execution, call that overridden version, right? Only two possibilities. Okay, I'll write it down. And then if you got any question, I can also answer. If some class does not override equals, you're going to call the default version. Of course, default version comes from the object class, which is always there. Okay, possibility number two. If some class that you're looking up contains or overrides equals, call this version. All right. Let me, again, just repeat again, right? Just overall, exactly what I'm trying to say here. And then you can ask me questions if you want to. So we start from every method call of the equals method. You're wondering about which version should be called, default version or the overridden version. To really determine that, you only look at the context objects. You can disregard the arguments for the decision making. When you look at the context object over here, you want to, at this point of tracing, X should be pointing to some object, otherwise it's a null pointer exception, right? So X must be pointing to some object with some title. The title here is so-called the dynamic type of X. Okay, we'll elaborate on this a little bit more later. But for now, just understand that at this point of execution, X is pointing to this particular object. And look at that particular class as a dynamic type. If that class does not override equals, call the default version. If that overrides the equals, you call that overridden version. Right? So that'll be the different steps you have to follow. Of course, we're going to practice using this. All right, any questions? Question?
Can you explain the part where X is dynamic? So are you saying that when we execute the code for some class, X might have the address change?
Yes, exactly. So let's say, for example, it's a very good question here. Okay, I'll try not to somehow, because if I go to exactly very broad or general, that could confuse. But let me just try as much as I can. Okay. So let's say, for example, it is possible to write Java code like this. Let's say you declare X, right? It could be that x right now is new point v1, for example. So that means after this one here, x is pointing to some point v1 objects. So we know that this is the current dynamic type for x. All right. Accordingly, if you try to call x dot equals something, given that its dynamic type is actually point v1, so we know that point v1 has no overridden version, right? Default version will be called. Default version will be called. Now, it is also possible, let's say later on in the code, you decided to reassign x. You might say x right now is going to be new point v2. And then in that case, what you're doing is x, rather than pointing to here, is now going to point to this object here with a different dynamic type, point v2. So think about at this point of execution, this is the new dynamic type. So now if you look at, right now, if I say x dot equals something, okay? If I look at x and also its current dynamic type, I know that the overridden version in the point v2 is going to be invoked. So you can see it's really the same reference variable. This one here and also this one here. However, at this point of execution, x dynamic type is point v1. At this point of execution, the dynamic type for x is point v2. So you call different versions, right? Depending on where you are.
So is the dynamic type the class of x?
The dynamic type is the type of objects x is pointing to.
So the type of object that x points to is the dynamic type?
Yes, that's correct. Yeah. So we'll put it in this way. You can see the way. I'm still trying to be a little bit more intuitive at this point because we need to be more 100% precise when we get to inheritance. But in this way, think about when you trace your code. If x is currently pointing to some objects, and look at the title of the box. Once you see the title of the box, that one is the dynamic type. Okay. We'll see more example. Okay. Good. Okay. Hopefully this clarify a little bit. Question.
For example, the actual type of the class is, for example, like a simple inheritance with animal and dog. So the actual type is dog. But when I passed it to the method, I passed it as an animal itself. I passed it as the parent. When I call the equals method, will it call the parent method or will it call the child method?
Okay, the short answer is you call the overridden version in the closest ancestor. But that's the short answer. But we're going to exploit that exact definition for that. So it's going to take some time. Maybe not at this point. Okay, please bear with me. Okay. So guys, any question so far about here? Hopefully it's still not too bad, right? All right. So after this, let's now try to do example. Okay, so let's now revisit the page that we kind of started. I'm not sure, maybe we did. Anyway, so let's do this again. Okay. So what's the context here? So we have our object class and we have our point v1, which has no explicit overriding of the equals, right? Let's just keep repeating that. And let's now try to execute some code. The line number 1 over here is a string objects, but let's just visualize it. That might be useful for later. So this one here, we have S that points to some string objects right here. Okay, string. And then the value is simply 2 and 3, right? Like a character sequence, right? I'm just being a little bit more informal here. Okay, it's an objects there. Dynamic type, string, all right? And let's now take a look at the next 3 lines, okay? So how do you tell the dynamic type? Now I'm telling the principle to decide, right? If you just want to look at Java code. Let's now, first of all, highlight the 3 lines here. 1, 2, 3, okay? I'll zoom in. If you look at these 3 lines, the type over here, on the left-hand side, declare type, right? We say it's the type of the variable. All these 3 are the same. Also, the constructor that we are calling on the right-hand side, 1, 2, 3 are also the same, right? Or specifically, this class over here is the same as the constructor name. This class over here is also the same as this constructor name. It is okay to live with this just for now. But I want to tell you that in general, these two names do not need to be the same once we talk about inheritance. But at this point, you can assume they will always be the same at this point. All right? Now, which ones correspond to dynamic type? You want to look at this is not a dynamic type. It's, by the way, something called static type, which I will elaborate a little bit more maybe next week. Okay? Look at only the constructor names you are calling. So these are the dynamic type. All right? Think about dynamic because you're creating new objects, and the new object you're calling, you're creating may call different constructor each time. So that's why it's dynamic. Okay? So here, let me write it down. The name of the constructor is going to determine the dynamic type. Very important, all right? Let's now try to look at the visualization, okay? So we got P1, P2, P3, P1, P2, and P3. You can see I put the title of the box, point V1, point V1, and point V1. They all correspond to the point V1 right here, all right? They all correspond to this. So I can do it again. Think about all the point V1 over here. They are the dynamic type. They just happen to be the same for P1, P2, and P3. All right? So let's now write it down. Dynamic type. All right? That's how we start with. And let's now consider just first, okay, so the first, these two should be rather straightforward. P1 equals P2. No, false. Different objects. P2 equals P3. Also, different objects, right? Should be false for both. False, false. Let's now look at the next few lines. Let's see here. Now, let's now try to do this systematically. How many equals method call do we have? 1, 2, 3, 4, and 5. Remember the principle. To determine which version is going to be called, we have to look at the dynamic type for the context objects. So all these don't really matter for our decision making. We only have to look at the context objects, right? Let me highlight the context object first of all, okay? And then why don't we figure out the dynamic type, all of them first, and then we can know how to predict the behavior. So all these, P1, 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 P2, right? So we only got context object being either P1 or P2. Their dynamic type, the same, point V1. What does that mean? That means to determine which version of equals is going to be called, go to the dynamic type, which is point V1. Go to point V1, do we have an overriding method for equals? We don't. That means use the one inherited from objects. So that means for all the equals method call in this example here, we're all going to call the default version from the object class. All right, I'll write this conclusion down so I don't need to repeat it, like 5 times. Okay. So let's now do that quickly. So all the context objects have the same dynamic type. All the context objects have the same dynamic type, point V1. Okay, that's step number 1. We figure out the context object dynamic type. And step number 2, point V1 being the dynamic type has not overridden the equals method. That's what we observed, right? You can see for the whole definition, there's no equals method. Number 3, the conclusion. Therefore, the default version from objects will be invoked for all the method call on the equals. All right? Of course, in the actual maybe test or exam, if I give you a different method call, different context objects, you have to somehow determine maybe one by one. Just for this one, I kind of designed that way. So they just happen to be the same dynamic type. Right, let's now look at one by one, okay, just to emphasize Okay. So first of all, we have P1 dot equals P1, right? So I'm going to call the default version over here, right? So let's do a little bit more efficient tracing. So if you recall the way we kind of did the tracing back in OOP review, let's say this one here. P1 over here is the context objects. Every occurrence of this is going to be replaced by P1. And P1 over here, of course, you can talk about call by value, but for now, we don't need to, okay? So every occurrence of the object's arguments is going to be replaced by P1. All right? So that means line number 7 boils down into P1 equals P1. It's almost as if you wrote P1 equals P1, as if, right? In this case, because we're calling the default version. And that one there is going to give you true. An object has the same address as itself. Okay, next one. What about P1 dot equals null? What does that boil down into? P1 equals null, right? Line number A boils down into P1 equals null, right? Basically, just replace every occurrence of OBJ by null and null over here, right? And that one there should be false because we know that P1 is not null. False. All right, line number 9, very interesting one. Okay, let me first of all just show you the tracing, and then we got to discuss it separately as well. Line number 9. Okay, line number 9, P1 dot equals S. And remember, S is a string reference, right? So now, every occurrence of this is P1. We did already. Every occurrence of OBJ is going to be S. So P1 equals S, right? It boils down into P1 equals S. Intuitively, we are basically asking, are these two objects have the same address? No, right? Different objects. It's going to be false, this equal method call, all right? Let me pause here, all right? To be 100% precise, I would like to put these in quote for a reason, all right? You may be already wondering about, is this really possible to do it? Okay, let me open a new page, okay? Let me talk about it separately, okay? This is subtle but important, okay? Let me now recreate what's happening in that particular line, okay? All right, so first of all, let's now talk about, we have point V1 and then P1. And then we got new, right? Whatever it is. And then we got a string object S and then some value over here, all right? Let's visualize it right away, okay? So what we got is we got P1 storing the address of point V1. So point V1 is a dynamic type for P1, okay? And then you can think about here is point V1, right? The constructor being called. And then S is pointing to some string objects. Okay, straightforward. And now, let's now consider these two. P1 dot equals S, right? Remember, that's the line we wrote right here, okay? And that one there, we know the answer should be false because it boils down into, I put in quote, P1 equals S. The context object this equals OBJ, the arguments. And we know that evaluate to false, right? That's something we just said. But now I want to write another one. What if we said, I don't want the equals method. I want to do this one directly myself when I want to compare the P1 and S by their addresses, okay? If I write this, oh, sorry, not this one. If I say P1 equals S, what's going to be the result? Seems to be a Boolean, so that should really give you either true or false. Seems to be. So now the question is, for number 2, which seems to be a Boolean expression, should we get true, or should we get false, or should we get something else? I heard false first. Okay.
I think it might be a type mismatch. I'm not sure.
Type this match. How come?
I'm not sure, but because they have different object types.
Yeah. Okay. Very good. All right. All right. So this one here, you can feel free to try. This one here is going to be a compilation error. Whenever you want to compare addresses, you have to compare addresses of the same type. Remember how we declare them. These are the declare type. Declare type, different. Forbidden to compare their addresses directly.
What happens if I casted one of them to the
Let's not worry about casting for now. That's going to complicate the matter. Yeah. Right, so if you simply got two objects of different declare types, you want to compare their addresses using equal, you just cannot do it. Compilation error. Yeah, go ahead.
So for one, are we using the default version of equals, or are we using like the version of equals that we can find in string?
Well, so one there is like what we discussed earlier, right? So P1 has a dynamic type, point V1, as you can see in the diagram. So that means it's going to call the point V1 version. And point V1 has no overridden equals. So we're going to call the default version.
The version of equals found in the context object?
No, you always go for the dynamic type for the context objects, right? So again, the principle is look at the method call here and only go to the context object, which is P1. And P1 is currently pointing to point V1 object. So this is the dynamic type. So you go to the definition for the dynamic type, which is point V1. When you go there, you can see there's no explicit overriding for the equals method. In which case, you know that you have to use the you have to use the default version that's inherited from the object class, right? Okay.
I'm also wondering for two, where you did the equal, it's wrong because they're not the same dynamic type.
They are not the same. Okay, good question here. So that's why I kind of annotate right here. P1 and S, they have different declare types. Remember, dynamic type you have to look at right here, right? When you look at the dynamic type, you have to look at the constructed name. So they're different, right? Declare type and dynamic type, they are different concepts. For now, we don't have to distinguish so detailed just yet. Maybe on Tuesday next week, I'll do that. But for now, just remember, when you want to look at dynamic type, look at the constructed name here.
So are we looking at the declare type
For that address comparison, yes, that's correct.
when we're looking at the declare type, like when we use the constructor, does the constructor affect the declare type at all? Like if you have an
They are somehow related. Okay, so you're basically asking over here, so declare type, dynamic type, are they impacting each other? To some extent, yes, in some way. However, exactly how they're related to each other, I will delay that discussion until we talk about maybe inheritance, because that does require quite a bit of explanation. So maybe we wouldn't do that today. So remember just that declare type is this. This is dynamic type. Right now, they happen to be the same, but they don't have to be in general. When they are not the same, there are certain rules you have to follow to really justify if they are valid. But we'll talk about those rules later. Okay? Yeah.
The reason the comparison in the equals method works is both objects get
Yeah.
upcasted to object type.
Okay, I wouldn't use the word upcast. That might confuse a fellow student who haven't talked about cast before. Let me put it this way. Okay, so now this one doesn't work, compilation error. But this one here compiles and it's going to return false. What's the reason? Reason is simple. All right, all you gotta do is, okay, I'll put it here. This one here compiles because, right? Look at S over here. When you look at the header of the equals method, right? Because when you look at Boolean equals, the type of the parameter object is called objects. So that means whenever you're calling the equals method, you can pass anything. anything in Java by definition is an object. Anything. Can be person, can be point, can be string, anything. Okay? So that's why when you say p1 s, it's simply going to compile. Because s over here is an object which will satisfy this criteria. Right? Criterion. All right? Any type of arguments is acceptable. So this somehow boils down into comparing their addresses. That's okay, because it's not exactly done by you. It's actually done by the runtime, according to the default version. And then this one here is not going to compile because the declare types of the two variables are different. Right? Question?
So when you say that any type can be an object, does that also include primitive types?
Primitive?
Yeah.
That's a good catch. Any reference type is objects.
So any reference type?
Any reference type, yeah. So you wouldn't say integer, like an int, is an object. You wouldn't say that.
I don't think.
Yeah, because object, like a capital O, is like a reference type concept, right? So you would say any reference type is an object. Yeah. Okay, good catch. Yeah.
So if we pass in like an integer 2, it wouldn't treat it as like integer capital I. Integer.
Okay, that one's more like something like I forgot it exactly, like unboxing, something like that. But let's not go there. Okay. Yeah, it's a bit kind of complicated matter. Yeah, because Java does do something automatically for you. Sometimes it might be confusing to everybody, right? So let's not worry about it. Okay. Guys, are we good? All right, quite a bit of stuff. I just hang on there and then try to study that. Try to pay attention to detail and then ask me for questions, right? Let's take a short break that you deserve, all right? All right, we got about half an hour. I would like to do one more example for call by value, just to, again, revisit the principle about call by value, and then we try to bring to the context for equals method call, just a method call, but just make it more direct. And then I want to talk about short circuit evaluation, which is one of the practice questions in your, for written test 1. Okay, I'll talk about it as well. That should be it for today, but definitely going to take half an hour. All right, so let's now talk about how the call by value can be understood in equals method call, right? So let's see this. Let's say, let me choose a line of method call. Let's say this line here. Let's look at this line of method call. All right. So here we got P2, P3, right? P3 is the arguments, right? And apparently we know which version of equals is going to be called, because if you look at P2, P2 has the dynamic type point v2, which is, let me say it again. So when you initialize P2, it's going to be point v2 right here, right? Let me put it down. So think about point v2 here is the dynamic type. Or you can think about right here, this one here is the dynamic type for point v2. So when I make this method call, P2, context object, I know that dynamic type is point v2. When I go to point v2, do I have the overridden equals? I do. So I'm going to call that version, right? All right, and then I'm just going to box this method as well, the equals method here, right? So at the runtime, this is going to be called. So I got method call here, and this is a method declaration. So we got call by value. Okay, so what I have is right here. All right. Guys, hello. All right, thank you. All right, so here we got a method call here. And then what we have is we got arguments, P3, and we got parameter, obj. All right, so we know right away the call by value is going to proceed as follows. Obj is assigned P3. All right, so P3 is simply this object right here, right? If you want to trace it, it's going to be 4 and 5, right? You can do that. So P3 is right here. Obj is just going to copy P3's address. So you'll be pointing to here. All right? And then, if you like, think about this right here. This will be the context object, P2, right? So you can think about this is also referring to P2, right? Now, when you actually try to trace this fragment of code, whenever you see OBJ, 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 and OBJ, you will know that OBJ is pointing to the same objects as the P3 arguments. On the other hand, whenever you see this right here, that means we are referring to the context object, P2, right? So this is something we also did, we just did not long ago. Any question? That's call by value again. Question?
So when we're overriding the equals method in point V2,
yeah.
Why are we saying that the parameter is the type object, not point V2?
Good question. So two things to answer, okay? Number one, yes, it is possible for you to declare some more specialized version where you simply say point V2 over here, which will correspond to the class. It is okay. Yes, you can do that. However, it is not general enough for comparing the equality between objects. You want to think about when I want to compare myself with any other things. I can compare myself with a chair. I want to compare myself with another person. I want to compare myself with maybe a desk. You want the argument to be as general as possible so that the equals method can always give you either true or false. However, if you restrict your parameter to be just point V2, then sometimes you may not have that definition for, let's say, if you compare point V2 with something else. Right? It's more like a design issue over here.
So follow-up question. If we say we have that as point V2, and we decided to compare with a string, so we give it an argument as a string, would it go to the
short answer, if you did. If you actually, so let me mention that shortly because it's not more complicated than you might think, okay? Hypothetically, if I change this guy here to be point V2, all right? And then here I say, let's say P2, let's say it's point V2 objects, all right? And then the equals, okay? And here I'm passing, let's say, string, all right? This one here will turn out not to be calling this method here because that one says point V2. What that would do is instead it will actually call the default version that's inherited because that one there now is considered as different version as this equals method here, right? It's different, right? That one there, I wouldn't go that far for that complication, right? That one's a little bit more about playing with maybe the parameter type, which we don't have to in this course, all right? Okay, but it's a good question, but I'm just saying it may not be doing what you're thinking.
Because I was thinking maybe we could just get rid of some lines.
Yeah, I think so the equals method we are doing here is the most general one. That's a standard one. We want to be able to call equals on any argument objects.
That's right.
Yeah, okay, good. It's a good question. All right, so that's about call by value. So we're going to revisit about exactly how the overridden version here can be defined. There are different phases. For the first 2 or 3 phases are pretty routine. Right? So you basically just follow through almost the same, but we've got to understand the logic for those routine. There will be some logic to play with as well. We'll do that next week. And also the last part here is going to be the creative part you will have to do by yourself. But don't worry, we'll get there, right? So for now, for the rest of today, I think we should have enough time. I want to talk about something called short circuit evaluation. And once we cover short circuit evaluation, that will be the whole coverage, the ending coverage for your written test 1 next Wednesday. And then the short circuit evaluation, make sure you study that, is also going to help when we get to the part about equals method that's going to involve short circuit evaluation. So I think it's a good timing to do it today. All right, let's now talk about it. All right, first of all, let me start with this. Okay. Oh, actually, before that, let me do this one first. Okay, beg your pardon. So we are basically talking about 2, they call logical operators. So %, which we call the AND operator, or mathematically conjunction, right? Either you can say it's an AND operator, or you can say it's a conjunction. On the other hand, you also got vertical bar, which is the OR operator, or we call the disjunction, I'm pretty sure I've seen that maybe back in the math class, right? Let's now briefly go through the definition of the and or very quickly. I'm pretty sure I've seen the truth table before, right? So this is so-called a truth table because ampersand is a binary operator. So the way to use it, usually you will simply write something like this. Let me write it down, okay? You would say something like operand number 1, ampersand, operand number 2. Similarly, you would say something like operand number 1, vertical bar, and operand number 2, right? That's how you use it. It's a binary operator. And the requirement is both of these should be Boolean type, which means it can either be true or false. This can also be true or false. To enumerate all the possible combinations between these two, you got 2 times 2. You got 4, right? Simple math, right? Combinations. So you can get true, 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 false, false, true, false, false combinations. Question?
What's the difference between the single and the single or?
Okay, single and single or vertical bar, I believe is more about a bitwise operator, but we don't use that in this course. Yeah, that one is more about manipulating, some bits, in your number, but we don't have to go with that kind of manipulation in this course. So we're going to focus on double ampersand and double vertical bar. Okay, good. Okay, let's now just talk about this definition very quickly, right? So here is a definition. For ampersand, basically here is how you can remember it, right? So we say that the only way for ampersand to be true is when both operands are true. What that means is if any of the operand is false, it's going to be false. For example, you can see the second operand here is false. The first operand here is false, and both operands here are false. You get a false result, right? So the only way to make the ampersand true is when both are true. If not either or both of them is false, then it's going to be false. The vertical bar or operator is symmetric. Okay, so here the only way to make the or operator false is when both operands are false. If either or both of them are true, you're going to get a or to be true. For example, i.e., first operand is true, second operand is true, both operands are true, so you get true result, right? You can see the way we kind of defined it with the definition for and or are kind of symmetric, right? Whenever you talk about true, you may talk about false, right? All right, and then before I move on, I want to ask you guys a question, okay? Here, sorry, let me just make sure I got my notes. There we go, all right. Let's now do some very important distinction, okay? So first of all, let's start with math. Maybe 1019, I guess 1019. So if I say P and Q, right, that's a conjunction operator. And also P or Q, disjunction, all right? And also we got Java, the programming. Any mainstream programming language like Python, C#, C++, they all support like a logical operator. So the discussion here is definitely not just for Java. So we got P and Q. And also P or Q. All right? So here's my question. Is the conjunction operator completely equivalent to the AND operator in Java? Also, is the disjunction operator in math completely equivalent to the OR operator in Java? We're basically saying, can we simply understand the meaning between math and programming just the same? Can we? If you don't think they are exactly the same, tell me how.
the first expression is enough to determine the answer, you don't do the other
Yeah,
expression.
yeah, pretty much. It's definitely on the right track. Yes,
So if
yeah,
P is true, then you don't need to do Q, and the same case for
yeah.
But can we do that also like in our heads, like when we're thinking, when we're doing actual math with P and Q?
Yeah, well, how I think you more talk about strategy for solving problem. We are more talking about like a general meaning, right? When you say P conjoined with Q, does it really mean exactly P n% Q? That's what we're asking. Exactly how you approach the evaluation for P conjunction with Q is a different story. Just like an orthogonal issue, really. Yeah. Question?
So when you say that if they are equivalent, are you talking to when we are comparing truth values?
Equivalent in the following sense. Do they behave the same? More thinking this way, in Java, you're basically talking about runtime. At the runtime, we're going to evaluate P n% Q in a particular way. Is that kind of evaluation corresponding to what we understand about the conjunction in math? That's what I'm saying. The programming runtime behavior, does it 100% correspond to how we understand about the conjunction operator, for example?
So do you mean like the concept of the conjunction operator?
Yeah, more like a concept of a conjunction operator or any a property associated with it. Does that get properly reflected in the runtime behavior for Java? All right, question or answer.
Like, you would get the same output for the same input. However, like, if, let's say P is very complicated and the Q is just true or false, your computer would do a lot more work than you would do in math, because you would just see that.
Interesting thought, but I may not be the direction to think about this. But I appreciate the thoughts. Okay, let me just say that. Okay, have you guys heard about something called commutativity? At least heard the term? Okay, I'll write it down. Don't worry. Commutativity. Okay, what does that mean? That means when I say P and Q, it should be equivalent to Q and P. That one we agree. Doesn't matter the order, right? However, in Java, does commutativity exist? If it existed, that would mean when we evaluate P and Q versus evaluating Q and P, are they going to give us the same behavior always? Huh? They say, okay, right, because when we talk about programming, we talk about behavior at the runtime, right? The answer is no. Yeah, I agree. No. Okay, we got to explain that exactly.
Like the example showed the division by Z. One will give
Yeah, exactly. Yeah. Don't get too much ahead, right? That's good. I appreciate that. Good. Okay, good. So this is actually going to be not identical. But as you said, right, it's something called short circuit evaluation. So this page over here is more like a very important knowledge to really know. What we talk about as a logical operators in programming is not exactly like a logical operator in math. Not exactly. And the key word to really remember is commutativity. All right? Let's now talk about it, as your fellow students, you're saying. All right? Short circuit evaluation. Let's talk about the definition, and then we'll do example. Okay? Let me start with, again, the AND operator. Okay, so let me now do this one here. Okay. So first of all, we have to evaluate from left to right. Always, left to right. So operand number 1 should be evaluated first. So 2.1. If operand number 1 evaluate to true, okay? What does that correspond to? So it's going to be, let's say, blue. Operand number 1 is true. That means we got over here, and also we got over here, right? 2.1. 2.1 tells you, if I know that the first operand is true, if second operand is true, ultimate result is true. If second operand is false, ultimate result is false. So we do have to evaluate the second operand to know what's the final result. So we need to, all right? Evaluates operand 2 to decide. the final result of ampersand, ampersand. All right? 2.2. Let me use a different color, just to show to you. 2.2. If operand number 1 evaluates to false, right? What does that correspond to in the row? So you can see first operand is false, and also right here, right? When the first operand is false, doesn't matter what this is. It can be true, can be false. The result will just be false regardless. So you don't need to go ahead. All right? In that case, skip. The evaluation of operand 2. The final result of ampersand ampersand is false. All right, so that's the definition. All right, the OR operator is going to be symmetric. So let me see if this might work. Let me give it a try. Okay. Okay, let me give it a try. All right. I'm just going to change accordingly, so don't worry. Okay. Okay, so now for OR operator, we're still going to evaluate from left to right, the same. All right, so now if operand number 1 evaluate to, now in this case, let's change, right, accordingly. If operand number 1 evaluate to false, then we have to go ahead and evaluate operand number 2 to determine the result for OR. What do I mean? All right, so 2.1 goes like this. So 2.1 is when operand 1 evaluate to false. False and false. Oh, sorry, I beg your pardon. I saw the wrong column. So operand 1, false and false, right? So we're basically talking about this column, this row here, and also this row over here, right? So these two are 2.1. In which case, you can see if operand number 2 is false, result is false. If it is true, it is true, right? So we got to determine. We got to evaluate operand number 2, all right? And then step 2.2. And then if operand number 1 evaluate to true, right? We're going to modify that to the OR operator. Guys, not yet. Okay, right? If that's true over here, and then we're going to skip the evaluation, and the result is going to be true. Okay, let's see. So now for this one here, so if the operand number 1 evaluate to true, so this one and also this one. So these two are 2.2. Are 2.2. So you can see the first operand is simply true. In which case, doesn't really matter if this is false or true. It will just be true anyway. So we can skip it. Right? So the fact that I just simply did a copy and paste and also modify the corresponding part kind of tells you that the way we think about and OR are kind of symmetric. That's also a very important message. You don't really kind of memorize this kind of stuff, right? Once you understand one, or just understand the connection between the two operators. All right, let's now do one example here. Okay, just one. Let's say this. What we have is, we have y divided by x, right? This is an expression that might run into some so-called division by zero exception, right? So division by zero exception if x equals 0. All right, we know that pretty well. All right, and right now we actually put some Boolean condition here before the expression. Let's see how the short circuit evaluation is going to work. Okay, so let's try that. The first one here, if I try x to be 0 and y to be 10, In this case, I really don't want to reach this point to have x being 0. I don't want to. But let's see how we can avoid it using short circuit evaluation. So let me copy down this expression here. Okay, I'll put it here. So x will be 0, y will be 10. So 0 not equal to 0, and 10 divided by 0 larger than 2. Mathematically, you can already see the right-hand side there is not well defined because division by 0, right? But now, at runtime, what's going to happen? Let's now evaluate this. 0 not equal to 0, false. Agree? 0 cannot be equal, 0 must be equal to itself. When you say not equal, it should be false, right? I was kind of stuck at this point yesterday, but I'm a lot smarter than yesterday, all right? So false here, what does that mean? Short circuit evaluation, if that's false, you don't continue. Skipped. So effectively, we have avoided the crash, or like an exception. On the other hand, if we try 5 and 10, all right? So now 5 and 10. So 5 not equal to 0, and also 10 divided by 5 larger than 2. How about this one here, right? 5 not equal to 0, true. They are not equal value. So that means I have to go on and go to the second here. And then I can simply go ahead and evaluate whatever that value is, right? Just because at least I wouldn't run into division by 0 exception. Okay, so give a try on the tracing for these two x and y's on the OR operator. But I do want to summarize in one page about the general design principle, all right? Over here. Okay, let me see this. So what you would, when you compare these two examples, let's see here, okay? So what I have is I got x not equal to 0 and some expression about y divided by x. When I get an OR operator, I got x equals 0 or y divided by x. All right, right here. So if you just copy down, the expression, you got this. All right. Now, we know that, again, this is the expression we would like to somehow protect. This is some expression to protect. You don't really want to evaluate it when you can trigger some exception to protect. All right? And then you can see that these two Boolean conditions are not the same. However, they are related to each other. Not equal to and equal to. They are logical negation of each other. All right? They are the logical negation of each other. And more specifically, we say that this one here is the so-called guarding condition for the AND operator. Guarding condition in the sense that if the guarding condition is true, pass it, go to the second one. If the guard doesn't pass, you don't really go to the second evaluation, right? Without passing it, skip the second operand, right? That's how you understand it. That's why it's called guarding condition. On the other hand, this condition here is so-called error condition. Meaning that if the error condition is true, you don't really evaluate it, all right? If it is true, that means there's some potential error risk. Skip the second operand. All right, so that's more like a design principle. So whenever you got some Boolean condition for the AND operator, if you're kind of wondering about what would be the kind of equivalent one in the OR operator, you can think about the logical negation. All right, one more example, one more. Let's now try to see another example where we have this. Let's say we got an array A, which we assume to be an array of some values. Exactly what values they are, doesn't matter, just an array with indices. Okay? And let's say we say A dot length is simply equal to 10. Indices would be 0 to 9. That's our assumption. Just make it simpler. I'm going to write down some Boolean expression. Tell me whether or not it's well designed. Okay, I'll write it down. I, some index, some integer, larger than or equal to 0, and A array at index I equals some value. Okay, and also I less than or equal to A dot length minus 1. Okay? Guys, I may have to run overtime just for 1 minute today. Okay? So let me finish this. Okay? Quickly, anybody? Is this appropriate? Appropriate in the sense that, is this always guarded? Is this always guarded? The answer is this is not guarded. Can you give me one example of I that's going to trigger some exception? Sure. The answer is no. For example, if I is equal to exactly the length of the array, which is not a valid index, right? 10. You can see 10 is not part of the valid index range, right? It's 10. Okay? So now, guys, please give me 1 minute, all right? I appreciate that. Okay? So now if I evaluate this, 10 larger than or equal to 0, true. Short circuit evaluating tell me that I should really go ahead and evaluate this. And then I'm actually going to evaluate when I is actually equal to 10. I'm going to go for A10. This is going to trigger the index out of bound exception. So this is not the way to go. All right? So 2 things, and then I'll let you go. All right? So what will be the correct way of writing it? Okay? Let me say this one here, let's say this one here, and also this one here. Let's call this one here guard number 1, guard number 2. Okay? The correct design should be you want to put all the guarding condition before the actual expression. All right? I'll write it down. Okay? So G1 and also G2, and then whatever expression you have about AI. You can swap the order of G1 and G2. That's okay. Doesn't really matter which one you got first. And one more thing. Exercise. Can you somehow rewrite the correct solution here rather than using ampersand, use OR operator? That's going to be useful, all right, for you to think about. All right, thank you so much. And then we got Saturday for the review session. If you want to join, 4 p.m., I'll be there. If not, you can try to release the recording later. Thank you so much.